My name is David Levy.
Now. Okay.
Hello, my name is David Levy. You are listening to the Observer's Notebook podcast. Enjoy.
Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 157, The Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the podcast, and also the coordinator of the training program within the ALPO. Thanks for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it alive. If you enjoy what you hear in the podcast, you can donate to it via Patreon. You can start by giving as little as $1 a month. If you feel even more generous, for $5 you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook, which is the training program handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon.com/observersnotebook. And if you'd like to join the ALPO, membership begins at only $18 a year. For more information, find us on the internet at www.alpo-astronomy.org. And you can also find us on Facebook. Just search for ALPO Astronomy. And this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear on podcasts, please subscribe. That way you'll never miss another episode. And now, Happy New Year. And every year at this time, we always do one podcast, and it's the Comet Podcast. Carl Hergenrother comes on to talk about the comets of 2023. Enjoy. All right, welcome everybody back to this edition of the Observer's Notebook podcast, and it's the first of the year, and every year, the first of the year, we have the same podcast with Carl Hergenrother, the Comets of 2023. Welcome back, Carl.
Thanks for having me, Tim. Yeah, I guess it's already been a year since the Comets of 2022.
That's crazy. Yeah, it's been an interesting year in the comet world, too.
Yeah, there have been quite a few nice comets this past year, and it seems like every year is a productive year for the ALPO Comets Section. Mm-hmm. And just to kind of remind everyone out there that anybody who's interested in observing comets, or either you're already observing comets or you want to observe comets, the ALPO Comets Section tries to produce some nice resources that we publish monthly, so you've kind of have your finger on the pulse of what's going on in comets out there. And we're definitely interested in all types of observations. Usually we work with magnitude estimates. That's where people will actually look at a comet and they'll figure out how bright it looks, comparing it to stars, or drawings or images. But even just a description of a comet, something as simple as, hey, it's a round, fuzzy thing with no color, which is like what 95% of the comets look like in a telescope. All that is great. If you want to learn more about the ALPO and the ALPO Comets Section, you can visit us at alpo-astronomy.org, and you can find a Comets section from there. Every month, we do publish what we call the ALPO Comet News, and that's kind of up-to-date information on these comets, where I go through and I analyze the brightnesses, produce new light curves, try to make predictions as to how bright the comet's going to be for the upcoming month. And you can find those also on the ALPO website. But I also post kind of a truncated form of these comet news reports on the Cloudy Night forums. So if you go to Cloudy Nights and just search for ALPO Comet News, you will find the comet news for that particular month. And there you'll get the latest and greatest information, as well as a way where you can ask questions and talk to other people who are observing comets. And ultimately, the goal of all of these observations that we're collecting at the ALPO is to reduce the data and learn something about these comets and actually publish the results. And in the past year or two, we've published results on Comet Neowise, the almost great comet of 2020. Published that about 2 years ago. And this was all in the Journal of the Astronomical Lunar and Planetary Observers. And also published a thing on the comets of 2019. And just as of a couple of days ago, I submitted part 1 of the comets of 2020, which will focus on 6 of the 13 comets that were well observed, and the other 7 I'll get to at a future date. And those articles can be read, I think, right now, because it's our 75th anniversary. You get access to those journal issues in real time, though usually you do have to be a member of the ALPO to get access to those journals, at least for about a year or two after they come out.
Yeah, and I got to add, the Comet section is the first section that published one of my observations. And this I hate to date myself, but this is Comet Kohoutek. And I was referenced in Dennis Millen's report of Comet Kohoutek. And I was in high school at the time. And to open up that issue, I didn't know my name was going to be in it. And open up that issue and see my name listed as contributing observers and have one of my observations in there, there's no greater motivator to make an observation and actually have it be published in a journal like the ALPO journal. So it was, to me, it really sparked me to go further in the organization as well.
Oh yeah, and it's actually same thing for me. My first observation that was published by the ALPO was a comet observation. Again, I was in high school, though this was a little bit later, late 80s, early 90s. I think it was Comet Austin.
Okay,
in particular was the comet. But yeah, very, very similar, just a few years later.
Very good. So let's talk about comets. Do you want to talk about comets for last year, or the ones we're ending now, or do you want to go?
So actually, I'm going to mostly be talking about comets 2023.
Okay.
A few of the comets that were good in 2022 do carry over into 2023. So I'll be talking about a few of those.
Okay.
But in general, what I want to do here is talk about those comets that are expected to become brighter in, say, magnitude 10. So things that are pretty easy to see in a reasonably sized aperture telescope from, your typical somewhat light polluted backyard.
Okay.
And so for 2023, there'll be about 10 comets that should get brighter than about magnitude 10. Of those 10, 5 are long period comets, 4 are short period comets, and we do have a Halley family comet returning as well. In fact, there's 2 Halley family comets coming back in 2024, one of which will be observable in 2023. But for some of those comets, we might actually wait for the comets of 2024 to go into a little more detail about those. But just to kick off, let's start talking about what will probably be the best comet of 2023. And this is Comet C2022 E3 ZTF. Now, ZTF is an acronym. It's actually the Zwicky Transient Facility. This is one of the NASA-funded professional asteroid surveys that is out there, sweeping the sky every night looking for mostly near-Earth asteroids, but also comets, and usually supernova and other kind of transient phenomenon. This C2022 E3 was discovered back in March of this year, 17th magnitude, which is a little bright for a professional discovery nowadays. And the Zwicky Transient Facility was using the 1.2 meter Schmidt telescope up on Mount Palomar. Now, this 1.2 meter doesn't have the most comet discoveries all time for a telescope. That's actually the SOHO spacecraft, which is well into the thousands. So the 1.2 meter Schmidt on Mount Palomar has a long history of discovering comets. It may not hold the record for most comets discovered by a telescope. That would be the SOHO spacecraft, which is discovered well into the thousands. But the 1.2 meter has been discovering comets back to 1949. Wow. And in fact, unless I've missed a comet or two here, it looks like they've discovered almost exactly 100 comets since 1949. And the 1.2 meter has been well known and used for things like the first and second Palomar sky surveys, the Palomar-Leiden asteroid and Trojan asteroid survey. A NEAT, Near-Earth Asteroid Tracking Program, was using that telescope back in the early part of the 2000s. And now, most recently, the Zwicky Transient Facility has been using the telescope. And basically, any comet that's got the name Wilson or Harrington or Abel or early Garrels discoveries, Kowal discoveries, Mueller discoveries, a lot of the neat stuff, ZTF and even Chiron, was discovered by this telescope. So it's pretty impressive looking at the history of this telescope.
That's amazing. I'd like to do a podcast just on that.
Yeah. It was actually fun
goes.
going through. And the great thing is there are discoveries by people who you don't think of as comet observers because they were supernova or quasar people.
Galaxy people.
But they happened to discover like Vandenberg and Sandage and Bod, or even one of my old bosses, John Hookra, has a comet discovery that came from using that the 1.2 meter. And so the Zwicky Transient Facility is using the telescope now, and talk about a wonderful backyard telescope if you can have one. Not only is it 1.2 meter F2 Schmidt, but it's equipped with 16 6,000 by 6,000 or 6K by 6K CCDs covering a 47 square degree field of view.
Oh my God.
Yeah. It sure beats my little 72 millimeter that's sitting in the backyard there.
The big eye in the sky.
Yep. So getting back to C2022 E3 ZTF, this comet is a dynamically old long period comet. What that means is that it's most likely has already approached close to the sun at least once in the past. That's usually pretty good because quite often when we get kind of fooled by a comet that looks really bright when it's far from the sun, it's because it's dynamically new. It's the first time entering the inner solar system. There's ices on it that have been frozen for pretty much the history of the solar system. And those ices sublimate, create a whole bunch of dust and gas, and make the comet look significantly brighter than it really is. And then as the comet comes in, it kind of underperforms. And we could think of comets like Ison and Austin, or as you mentioned before, Kohoutek, as kind of falling into that dynamically new bin. But ZTF here is a dynamically old comet. And the last time it was at perihelion was probably about 50,000 years ago. And the other nice thing about these dynamically old comets is they usually have a habit of brightening at least at an average rate or maybe even faster than average. And in fact, that's what the ZTF comet is doing. It's brightening at a slightly faster than average rate. So even though it was 17th magnitude back when it was discovered in March, right now it's around 9th magnitude. And going forward into 2023, in the beginning of the year, it'll be about magnitude 7. And if it continues brightening at this path, when it actually reaches its peak brightness, and we're talking like end of January, early February, it may be a 4th magnitude object, which is pretty cool.
Yeah.
So there's a few things going really well for this comet, in addition to the fact that it seems to be intrinsically active. Its perihelion is on January 12th at 1.11 AU, not super close to the sun, but close enough that it can get pretty bright. It also comes fairly close to the Earth, only about 2-3 weeks after perihelion. On February 1st, it will pass 0.29 AU from the Earth.
Oh, nice.
And the other nice thing, at least for us in the Northern Hemisphere, it is very well placed. This is not one of those, like Comet Leonard was, or even Neowise in the beginning, where, you have to stand on the roof of your house for the 2 minutes during the evening when you might be able to see the comet before it sets. The ZTF comet will actually be well north and even be a northern circumpolar object around the time when it's actually at its best. So you're talking about a comet that will start off in the morning sky, then be circumpolar all night long, and actually at its best at opposition, and well up, at its highest culmination, it'll be about 60, 70 degrees up, and about 4th, 5th magnitude.
That's great. Special. Easy to see.
Very easy to see. It does have an inclination of 109 degrees. So 90 degrees would be perpendicular to the plane of the Earth's orbit, plane of the solar system. So at 190 degrees, it is coming south. So even though it's going to be a great comet for northern observers at its best, it will remain visible to northern observers until it fades into the spring. Southern hemisphere observers will miss out on maybe the very best of the comet, but within about a week or two of perihelion, it will have moved far enough south that southern hemisphere observers can pick it up, and the comet should still be about 5th magnitude.
Okay, cool.
Again, we're talking about a nice morning into all-night comet, 6th, 7th magnitude in January, at the beginning of January, peaking around maybe 4th magnitude at the end of January, and it'll still be bright throughout February. Into March, it'll fade into 8th magnitude, and then we'll lose it at around 10th magnitude in April. So this would be a really nice comet to observe.
Okay, cool.
So one of the comets that was probably the best observed comet of 2023 will still be with us in 2024. and this is C2017 K2 Pan-STARRS. Now, this is kind of the opposite of ZTF. Here's a comet that is dynamically new. Possibly. There actually have been quite a few papers published on this comet, and they kind of, some of the go back and forth as to whether this is a dynamically new or dynamically old comet. But this is a comet that, unlike ZTF, which has been brightening at a faster than normal rate, this one has been brightening at an extremely slow rate. Now, this K2 comet has been interesting because, for one thing, when it was discovered back in May of 2017, so you're already talking, 5 years ago.
Oh, wow.
The comet was 18th, 19th magnitude and 16 AU from the sun.
It's huge.
Yeah, well, or at least very active back out there. Pre-discovery observations were found as far back as May of 2013, so we're almost pushing 10 years now.
That's crazy.
When the comet was 23 AU from the sun, which is further than the distance of Uranus. And peer-reviewed science papers that have been published on this comet, published specifically on the dust surrounding this comet, suggest that the comet may have been active as far out as 35 AU from the sun. So we're talking Neptune, Pluto type distances. But here's an example of a comet that's probably coming through the inner solar system first time, had very volatile ices that just have not seen any warmth in probably about 4.5 billion years, and got to 40 AU, and the comet just turned on, had a burst of activity, released a whole bunch of dust, and then maybe not much has happened since then. And so what you're seeing is this giant kind of dust coma, and as the comet gets closer and closer to the sun, the dust in the coma is falling apart and sublimating, almost like mini comets, producing a nice cometary tail. But unfortunately, as the comet gets closer and closer, it sort of underperforms. And we were really hoping this would have been a nice 5th or 6th magnitude comet at perihelion. And perihelion is actually still 2022, but December 19th, 2022. So just a little bit before the start of 2023. But as it turned out, this comet peaked around 8th magnitude.
So it's already at perihelion?
Yes.
Okay.
Or at least at the time of this recording, which is mid-November, we still got a few weeks before it gets to perihelion.
Okay.
But in 2023, it will, yes, be past perihelion.
Okay.
And so it's looking like it's probably going to be at about its peak brightness, maybe magnitude 7.5, magnitude 8 in January of 2023. And then since it was a very slow comet to brighten, those kind of have a habit of being very rapid to fade. So it may actually fade to 8th or 9th magnitude by the spring of 2023. Now, this comet was well observed from both hemispheres this summer, but has since gone far south. And so it actually is only a southern hemisphere object in the beginning of this year. Northern hemisphere observers will be able to pick it up again, probably August, September of this year. But by then, at best, it'll be a 10th magnitude object. It might even be a few magnitudes fainter by then.
Okay.
So the last of the comets that have been bright enough to have been easily observed in 2022 and should continue to be well observed in 2023 is another ZTF discovery. This is C2020 V2, which was discovered back in November of 2020 at 19th magnitude, which again was 2.5 years before perihelion, and the comet was 8 AU from the sun, so between Jupiter and Saturn. This comet doesn't get all that close to the sun. Perihelion will be on May 8th of 2023 at 2.2 AU, so twice the distance of the other ZTF comet, which will get up to 4th magnitude. Now, this one is also a dynamically new comet, or at least that's what its orbit shows, which means it also, like the K2 Pan-STARRS comet, is making its first approach close to the sun. And as I said before, usually those comets traditionally or usually brighten at a very slow rate. This one has been brightening at a normal rate. I wouldn't say it's a super fast rate, but it's been brightening at a more typical comet rate. Okay. And as a result, this comet is already around about magnitude 10 as of the time of this recording, and should be a nice 9th magnitude comet throughout almost all of 2023. That's one of the benefits of having a large perihelion distance at 2.22 AU. The comet, as its distance from the sun and Earth changes, it doesn't change very rapidly. So the comet can stick around for a long time. And so We've got perihelion in May at 2.22 AU. It only gets 1.85 AU from the Earth, but that's not until September. But it does look like this comet should be a nice 9th magnitude object for the first half of the year, when it will be observable only from the northern hemisphere. Then we will lose it around the April, May, June timeframe, just because it goes into solar conjunction. When it comes out of solar conjunction, now it'll be observable from both hemispheres, and should still be a 9th magnitude object all the way through October, maybe into November. So this one will be with us for a whole chunk of 2023.
That's great.
So the next comet on the list is C2021 T4 Lemon. And a little bit of uncertainty as to exactly how bright this comet will get. It was discovered in October of 2021 at 20th magnitude. It does get pretty close to the Earth, 0.54 AU, so half an AU in July of 2023, which is about the same time it comes to perihelion, which is at about 1.48 or 1.5 AU. And right now, this comet's sitting at about 15th magnitude. And it's also been brightening at a kind of typical cometary rate. If it continues brightening like that, then we could be talking about a comet that this northern hemisphere summer, so you're talking June, July, August, could get up to magnitude 8. If its brightness slows down, maybe it'll only get up to magnitude 9. But here's a nice object that will be observable mostly from the southern hemisphere. It'll actually be a difficult northern hemisphere object. Not impossible to observe, but this one will be a horizon hugger for the northern hemisphere. But the southern hemisphere observers will definitely have a very clean shot at looking at 2021 T4 linear.
Okay.
So the next few comets on the list are all short period comets. And so here's a bit of trivia, and I'll see if Tim can answer this.
Uh-oh.
What short period comet, when I'm talking short period comet, I'm talking, comes around every 5 to 10 years.
Okay.
What short period comet is usually the brightest? And would you be surprised to know that this comet routinely peaks at about 1st or 2nd magnitude and has even been observed to be as bright as negative 2nd magnitude at perihelion? And again, this is a comet that comes around every 5 years.
Oh, I have no idea.
Because, you'd be sitting there, well, if you're getting the equivalent of Neowise coming around every 5 years, how are we just hearing about this now? And this comet has an ALPO connection.
Really?
So this is 96P Machholz.
Don.
So yes, Don, who unfortunately left us not that long ago.
Right.
Don Machholz, who was a former ALPO Comets Section coordinator and discovered 12 comets visually, discovered this comet back in 1986, only a few degrees from M31, the Andromeda Galaxy. And talk about a trivia tidbit, Against All Odds by Phil Collins was playing on the radio when he discovered it. How do we know this? Because Don wrote up excellent stories about every one of his discoveries.
Yes, he did.
Which you can find on donmachholz.com.
Mm-hmm.
So I definitely suggest you check this out. Now, getting back to the trivia question, how is this comet always getting up to negative magnitudes, or at least bright 1st, 2nd magnitude every 5 years, and you've probably never seen it? The reason is, at perihelion, it is only 1/10 of an AU from the sun.
Wow.
And so it's almost always within a few degrees of the sun. So the only reason why we know it gets that bright is because we have SOHO observations that show the comet that bright.
Interesting.
This is a comet that rapidly fades as it moves away from the sun. So for this year, perihelion is at the very end of January 31st, as I said, at 0.11 AU from the sun. This will be its 8th observed return. And it will only be a northern hemisphere object, but it really will be a horizon hugger for those of us in the northern hemisphere. And only for a couple days in February, when it might only be a couple degrees above the horizon at the end of astronomical twilight, I should say before the start of astronomical twilight in the morning sky, we have a chance of observing Machholz. By the time it does get far enough from the sun for us to see, it definitely will not be 1st, 2nd magnitude. It might be 7th or 8th magnitude.
Okay.
Now, it's definitely an extremely interesting object. So even if you can just get a sight of it at all, it'd be well worth it. This comet is split. The last 2 returns is split multiple fragments that were observed in the SOHO frames. It's got a large nucleus, about 3 kilometers. That's pretty large for a Jupiter family comet. And it's part of what they call the Machholz planetary or interplanetary complex, which means it's related to not only itself, 96P and the pieces that it's been splitting off, but also asteroid 2003 EH1, which actually was a bright comet in 1490. 2003 EH1 is the parent body of the quadrantid meteor shower in January. It's also related to the daytime Aretid meteors, the southern delta Aquarid meteors, which happened, I think, late July, and the Cratched and Marsden group of sun-skirting comets. Not quite sun grazers, but a bunch of comets in 5-6 year orbits that get close to the sun. So Mach-Holtz may be the biggest piece, or at least the most active piece, of a large collection of bodies which have been probably breaking up for hundreds to thousands of years.
Yeah, wow, I did not know that.
Which is pretty amazing.
Yeah.
And the other amazing thing is Don's other short period comet, 141P Mach-Holtz, which Mach-Holtz 2, that is also a member of its own complex of related objects, is related to other comets and meteor showers and asteroids. So it's pretty cool that he discovered 2 of these objects that have been breaking up over the past millennia or so.
Can I take a detour for a minute here in this conversation? Mm-hmm. Let's talk about Don for a minute.
Yeah.
How well did you know Don?
I didn't know Don all that well. I've only talked to him a little bit.
Okay. All right. Yeah, I've known him. I think I met him at Big Bear when he discovered his comet there.
Right.
And he's been on the podcast a number of times. Always an excellent guest. Yeah, but he's really missed in the astronomical community. And his wife's doing a good job trying to keep his memory alive on Facebook and social media and reposting a lot of the articles he wrote. So
right.
Please, if you're on Facebook, friend Don Mackles, because it's his wife on his site now. And as you mentioned, donmackles.com, his website also has a wealth of information. So I really highly recommend any. You don't even have to be into comets, but just the way he wrote. And go back and listen to his podcast that he did with me. Because we talked about his history of observing comets and how this is the guy that started the Messier Marathon.
Yes.
That was his brainchild. So, he's done a lot for our community besides discovering comets. So he's an amazing guy.
Oh, yeah. So, and definitely missed.
Yes, definitely.
And very well could be the kind of last of his kind. The last visual discovery was a Mach-Holtz discovery.
All right. Well, let's talk about that for a second. I hate to do this, man, but all these comets you're talking about are discovered by these arrays of telescopes and large professional observatories. I don't know if David Levy is still out there hunting for comets, but are there any visual comet hunters out there that you know of?
Not that I personally know of. I'm sure someone is out there doing it. I'll have to admit, maybe I spend a few hours a year doing it, but that's definitely not enough to actually discover anything. When I was doing the Comets of 2020 paper, which I just submitted to the journal, one of the things I did was I kind of just gave a summary of the comets discovered in 2020. And there were no visual comets discovered in 2020. The last visual discovery, I think, was 2018. And like I said, that was a Don discovery. It was also discovered by 2 other amateurs, but they were imaging. But of almost every comet discovered, most were about 17th or 18th magnitude or fainter. There was one comet that was discovered around 8th magnitude, but that was discovered with a spacecraft, the SWAN instrument on SOHO. So I do think there are comets that occasionally can be discovered, especially if you're looking close to the sun, which you're not just competing against the Pan-STARRS and Atlases and Linears and CTFs and Catalinas. You're also competing against the spacecraft,
right?
The SOHOs and SWAN, which is also part of SOHO, as well as Stereo. And in the future, we'll also have to be competing against the Vera Rubin, what used to be called the LSST, which is going to be covering the entire sky every couple of nights down to 24th magnitude. And in a couple of years, there's plans to launch a infrared near-Earth telescope, kind of a bigger version of the WISE spacecraft. And that's the NEO Surveyor. So it's already extremely difficult to find any comets visually. And there used to be a time where you discover maybe half a dozen comets were discovered visually every year. And now we're lucky if we get one visual discovery a decade.
Yeah, the days of Kabasha, Burger, and Milan are gone.
Right. We are.
They really are. I mean, there's no one's looking up. They all have cameras attached to their telescopes.
Now, there are amateurs who are discovering comets through imaging.
Right.
All the Borisov comets.
Right.
The first interstellar or second interstellar comet was discovered that way. And like I said, Don's last visual discovery was also shared with two other observers who were observing with imaging. So even in 2020, there were 5 amateur discoveries, 3 of which were imaging from the ground on Earth, and 2 were using spacecraft data.
Wow. Okay. I'm sorry to derail you, but I just...
Oh, no, not a problem.
This is a topic I think we both like to talk about.
Yeah.
It's interesting. Okay, I'm sorry.
Oh, no. So moving on to the next comet is one that you may have heard of. This is 103P Hartley. Most people know this comet because the spacecraft visited it. The Deep Impact spacecraft, which hit Comet Tempel 1 back 2006 or so. After that impact, it flew past Tempel 1, went around the sun, and was retargeted, and actually flew by Comet Hartley, or actually it was Hartley 2 back when it was first discovered, in 2010. So this Comet Hartley 103P was discovered in 1986 by Malcolm Hartley, again using a 1.2 meter Schmidt, but not the one at Palomar. This was the one down at Siding Spring Observatory in Australia. And being 1986, this was a photographic discovery. This will be its 7th observed return. Long-time visual observers will probably remember that it had a good return in 1991. In fact, that was one of the first comets I observed visually back in 1991 when it reached 7th magnitude. It got up to 8th magnitude in 97. And then in 2010, and this was the year the Deep Impact spacecraft flew past it, the comet came within 0.12 AU of Earth and actually reached 5th magnitude. So that was its best return. This year's return kind of falls in between those good returns from the 90s when it got up to 7th, 8th magnitude, and that really excellent return in 2010. In 2023, Hartley 2 will come to perihelion on October 12th at 1.06 AU, and will come within 0.38 AU of the Earth on September 26th, so a few weeks before its perihelion. And this comet will be observable from both hemispheres. It'll be much better placed for the northern hemisphere, but you'll still be able to observe from the southern hemisphere. And it'll be a morning object, and it should peak around magnitude 7 or so in the September-October timeframe. Now, when I asked the question of what's the brightest of the short period comets, you had mentioned Encke. Well, Encke, which is kind of our frequent flyer of comets, because it orbits the sun every 3.3 years, will be back at perihelion on October 21st at its usual 0.33 AU from the sun. And this is definitely one of the most interesting comets, full stop, that are out there. I say that a lot because these are all interesting, but Encke's definitely there.
Yep.
It's got the shortest orbital period of any sublimating comet. I put the caveat sublimating. There is a quote-unquote comet called 311P Pan-STARRS, which has a shorter period, but it probably is really just an asteroid that spun up and fell apart and not your typical comet. With a small aphelion distance of just a little over 4 AU, Encke's is decoupled from the strong gravity of Jupiter, which means its orbit really hasn't changed much, probably over millennia. And so it's actually the sole member of its own class of short period comets, the Encke-type comets. It's the parent of its own meteoroid complex, the Taurid meteors, which were peaking just a couple weeks ago.
Right.
And studies of the orbital evolution of Encke suggest that it, the Taurids, and even a small number of near-Earth asteroids all are related to each other and possibly the result of a breakup event that happened maybe 5,000 or so years ago. Now, Encke, going around every 3 years, comes around often. And of course, the fact that it's 2P means it was discovered a long time ago. In fact, it was discovered on 4 separate occasions in 1786, 1795, 1805, and again in 1818. And it was discovered by Pierre McShan, who was kind of the competitor for Messier.
Right.
Caroline Herschel made one of the discoveries. Jean-Louis Pons made a discovery. So you may be wondering, why isn't it Comet McShan Herschel Pons? Why is it Comet Encke? Well, Encke is one of the few comets, the others being 1P Halley and 27P Crommelin, that's not named after the discoverer, but rather named after the orbit computer, the person who kind of linked up all of these past apparitions.
Okay.
This comet we saw in 1786, 1795, 1805, and 1818, it's all the same comet.
Okay.
So that's where the Enki name comes from. So except
fact.
for when it was missed once in 1944, it's been observed in every return since 1819. And so this will be its 65th observed return, which is pretty crazy. Or 66th. I may have got that wrong, but it's definitely been around a long, long time. So being a northern fall perihelion, it will not be observable from the southern hemisphere, but it will be a northern hemisphere object in the morning sky. And we'll be able to watch it as it's rapidly heads into the sun and should peak around maybe magnitude 6 before we finally lose it in the glare of dawn in mid-October. So our last short period comet is one probably no one's heard of. And this is 62P, and I apologize if I butchered a pronunciation, but the name is actually, it's the Purple Mountain Observatory in China, but it's the Mandarin pronunciation of Purple Mountain, which is Chuchinshan or Chuchinshin. So I could have that pronunciation completely wrong. But this was a comet, 62P, that was discovered photographically in 1965. It's its 9th observed return. This return will probably be its best return, not only that we've seen since discovery, but maybe even going forward. And the reason for that is that it had a relatively close approach to Jupiter only a couple of years ago. And its perihelion distance dropped down from its usual, it's usually up around 1.6, and then it dropped to 1.4, and now it's at 1.38 AU. And it will pass within half an AU of the Earth on January 29th of 2024. Now, perihelion comes a little bit earlier at the very end of the year. And so as a result, this will be a nice 9th magnitude comet in the morning sky for both hemispheres as the year ends, end of November, beginning December, and remain a 9th magnitude comet throughout January of 2024. So that ends the short period comets. We do have one more long period comet, C2021 S3 Pan-STARRS. This is a dynamically old comet, which is good. That means it's been around before. It doesn't come to perihelion until February 14th of 2024, and that's at 1.32 AU. It doesn't come closest to Earth until mid-March of 2024 at 1.3 AU. But because it's been brightening at a more of a typical rate, this comet should be bright enough to be seen in small apertures by the end of the year, though it'll be pretty much only southern hemisphere observers who will see it throughout 2023. And it should end the year around magnitude 8.5. As 2024 kicks off, and we'll talk more about this comet and the comets of 2024 a year from now, it becomes observable from both hemispheres and should peak around 7th magnitude in the March 2024 timeframe. So one of the interesting thing I'm really looking forward to in 2024 is we have not one but two Halley-type comets returning. Now, Halley-type comets usually have an orbital period between, say, 50 years and 200 years. Halley comes around every 75, 76 years. We've got 12P Pons-Brooks and 13P Olbers, and they both have orbital periods of around 70 years, and they're both coming back in 2024.
Oh, my.
Pons-Brooks will be brighter than 10th magnitude at the very end. Olbers will be more of a later 2024 object. So Pons-Brooks will probably peak around 4th magnitude in April of 2024. But as I said, it'll be 9th magnitude in December. Olbers will not be bright enough for most visual observers in 2023, but it'll be a nice 7th magnitude object in July of 2024. And the last time we saw these two comets, in the case of Pons-Brooks, that was 1954, when it got up to 6th magnitude. In the case of Olbers, that was 1956, which was about 6th or 7th magnitude. In 1954, 1956, you're actually talking a few years after the ALPO formed, and actually a year or two before, I think, the Comets Section formed. So these comets are coming back for the first time since the ALPO Comets Section has been a thing.
That's exciting.
But we'll talk more about those two comets and a bunch of other comets, including 144P Koshida and 333P Linear, and hopefully many more comets to be discovered. We'll talk more about those in the Comets of 2024 podcast a year from now.
That sounds exciting. I'm looking forward to many of these comets in the next year.
Yeah, it'll definitely be an interesting and an exciting year. Like I said, the highlight is this 2022 E3 ZTF. Should be a nice, fourth magnitude comet. One thing, if you look at its observing geometry, observing circumstances, here's a comet that gets about 1.1 AU from the sun. It gets within 0.3 AU of the Earth. It's easy to observe in the opposition sky. And in this case, going north to south rather than south to north, but it's very similar to Dawn's brightest comet that you can actually see from the ground. Not counting 96P, which is brightest in SOHO data, but his brightest comet for us mere mortals who don't have spacecraft was his 2004 comet. And that comet got up to third magnitude and was a big green fuzzball, naked eye, which was really nice. This comet may be similar. There is a big difference between the two, and this is also very exciting. This comet already shows a nice long dust tail that's already, visual observers have been seeing this dust tail for a few months now. Wow. So this may be more than just our typical big green fuzzball that we usually get when these comets get up to fourth, fifth magnitude. So we might actually have a little bit of structure here. We might have some jets. We might actually have a tail visible in, your C8. So I'm really looking forward to see 2022 E3. It's well placed. It'll be observable in the dark sky, and it looks like it's got a significant dust production. So it may actually show some things that we usually don't see when we got these more gassy comets that we're used to.
That's great. And the ALPO Comets Section, you have a blog on our website that people can go to and read about the latest. You update that normally?
Yep, as well as the ALPO Comet News that I produce every month. I try to get it out by the first of the month. I am usually not successful, but it usually comes out in the first week of the month. And they can
subscribe to that by sending you an email?
You can send me an email at comets@alpo-astronomy.org. In that case, for the ALPO Comet News, you don't need to subscribe. You can download the PDF directly from the ALPO website, or you can go to the Cloudy Nights forum that contains that month's comet news, and most of the material is right there in the ALPO. And if you need to contact me at all, send observations, just want to ask questions, then again, comets@alpo-astronomy.org.
Fantastic. Carl, once again, this has been enlightening and fun, and you got me excited about comets for next year. I want to thank you for that.
Thanks for doing these, Tim. Yeah, these are really fun. Yeah, and if we do get an exciting new discovery mid-year, or as we start approaching the time to observe the 12P Pons Brooks and 13P Olbers, maybe we'll do kind of a mid-year update.
That would be great. We've done those in the past, and anytime a new discovery, this podcast is a perfect vehicle for that. So let's look at that. All right. Well, thanks again for coming on the podcast today.
Thanks, Tim.
Well, that'll do it for this episode of the Observer's Notebook podcast. Again, I want to thank Carl Hergenrother for coming on and give us an update on the comets of 2023. We upload a new episode of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please give us a rating. Well, I really appreciate it. And you can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon, Echo, Spotify, and all these podcasts are also available on our YouTube channel. You can help support the podcast by donating to it via Patreon. You can give up to $35 a month, where you receive 1 year's membership to the ALPO and producer credits on the podcast. And it's been a while since I've done this, so I want to thank all of our patrons on this podcast. Jerry White, Jason Inman, Matt Will, Steve Siedentop, Matthew Benton, Ken Poshedly, Stephen Bennett, Michael Moyer, Shawn Dilles, Frank Schenck, Damian Allis, Carl Hergenrother, Julian Parks, Michael McShan, Michael Blake, and Nick Evetts. I really want to thank all of you. Steve Siedentop and Michael Moyer, they are producers on this podcast as well for giving a little bit more. So thank you, everyone. We would not have a podcast without you. The link for Patreon as well as the link for the ALPO is available in the show notes. And if you'd like to get a hold of me, you can. My email address is cometman@cometman.net, or you can reach me out at Twitter at ObserversNBPod. Until next time, my hope is you always have a clear and steady skies. Thanks for listening.